Question 1c. Let S be a bounded subset of R2. Deduce that the outer area of S is equal to the outer area of S closure. And to do this, I'll break up the work into 3 parts. The first 2 parts will be technical, and the third part will be to solve the question. So let rectangle R contain S. Let P partition R. So P is a partition of the rectangle R, and we fix epsilon greater than 0. So if we have RJKP, so the jkth rectangle relative to partition P, if that intersect S is empty, then this is by question 1a. By question 1a of this tutorial, we pick a subrectangle R jk prime contained inside R jkp such that the area of R jkp minus the area of R jk prime is less than epsilon over 9jk. And we also have it that R jk prime intersect S closure, that is empty. Okay. So what do we have here? Right, from question 1a, we have a rectangle here, and we also have a subrectangle. Okay, so let's name it. So this is R, J, K with a P, and we have this R, J, K prime. And we have it that this red shaded area has area less than epsilon over 9jk. So the area of the red part is less than epsilon over 9jk. So let's be a little bit more specific. If I were to then subdivide this into many smaller boxes, I could call this guy T1, I'll call this guy T2, T3, T4, T5, T6, T7, and T8. And I'll reshade it. So the area of all the TIs is less than epsilon over 9jk. So if the area of all the TIs is less than epsilon over 9jk, then the area of each individual TI will be less than epsilon over 9jk. So we also have area TI less than epsilon over 9jk for each I. And the way we achieve this is by adding an appropriate choice of delta to the partition, and that just comes from question 1a. So this can be achieved by adding that should be a plus. This to the partition. For a suitable choice of delta. Or suitable delta greater than 0. So we could do this for not just a choice of RJK, but we could do this for all possible RJKs. So we do this process for all RJKPs whenever RJKP intersect S is empty. So we make a quick note. There are only finitely many RJKPs. So without a loss of generality, we can assume that the deltas are of all the same value because we could just take the minimum of them. Aside, there exist only finitely many RJKPs that intersect S, which are empty. Because there are only finitely many RJKPs in the first place. So without a loss of generality, assume the deltas are the same value. So each RJKP intersect S being empty will produce a delta. Let's just assume all the deltas are the same value. Take them in. And this will work. It will still be a positive value. So therefore, we have a partition Q, which is a very big refinement of P. And note number 1, partition P yields a JK amount of subrectangles of R. Our partition Q yields at most 3J times 3K amount of rectangles, an amount of subrectangles. And these subrectangles are finer than those from P. So that's it for the first video.